Okay, Assalamualaikum and very good morning to all. Okay, here again we are going to do our next class for programming techniques under BCS1023. Okay, today we are going to focus on chapter 1, programming and problem solving. Okay, so basically programming, okay, so let's continue. Okay, for programming technique chapter 1, programming and problem solving. So in this chapter, I will focus on what is programming actually. Okay, so basically what is programming? Okay, so you know this person? Who is this person? This is basically the writer of Harry Potter, J.K. Rowling. Okay, so here J.K. Rowling wrote a Harry Potter series. Okay, and in her book, okay, you have this kind of script, a lot of script here, and then from the script, okay, Warner Bros. Pictures, which is a movie producer, take the script and create a movie. Okay, so everybody aware with this kind of issue, right? So we have, like, for example, we have Lord of the Rings, okay, a lot of book-based movies you have these days, like Twilight, example, right? So programming is almost like that, where you, as a programmer, write codes, okay, write codes, which will be read by the compiler to produce a binary and or also known as executable file. Okay, so this is what happened when you do programming. Okay, you go from programmer, write codes. Okay, you give it to compiler, and from the compiler they will produce a binary or executable file. Okay, so if you look at executable file, when I ask you what is where is your code, okay, submit your code. Don't submit the movie. Submit the script. Okay, when I tell you to submit the movie, the binary executable file, don't submit the script. Okay, so this is common problem when the students, because when you code, you will have two files. One is the code file which written in C, and then another one will be the binary executable file which is in .exe. Okay, when you submit your when I tell you submit your codes, means that you submit your script. Okay, when I tell you to submit your executable file, means you have to submit the movie. Okay, so please lash that in your mind about this. Okay, so let's go on towards the first chapter. So for programming, okay, programming task is basically we have two phases. Okay, so the first phase is the problem solving phase, okay, which is to produce an ordered sequence of steps that describe the solution of problems. Okay, where the solution is in a sequence that we usually call algorithm. Okay, so when you talk about algorithm, it's not about the codes yet, it's at the problem solving phase. And then next we have the implementation phase. This is where you implement the problem solving algorithm here into the program using a certain programming language. Okay, previously I did mention to you guys that I am not particularly well known in other programming languages, but I am very particular with C language. However, it doesn't mean that I cannot supervise uh, people who are coding with other languages, because in my area now, we only focus on the problem solving phase where I only develop the algorithm. The coding part will be handled by the coders. Okay, so this is common in computer science. We have developers and we have programmers. Okay, so developers usually they are focusing on algorithm, where programmers they write the program according to algorithm that has been discussed. So today, before we start doing a proper programming, okay, proper coding, okay, you need to know how to create an algorithm first, okay, because algorithm is the base of programming. If you do not make a proper algorithm, your programming will not work well. This is a common problem in programming. So firstly, okay, we usually, when we want to create an algorithm, we create a pseudocode first. Pseudocode, a pre-algorithm. When we want to design an algorithm, we create pseudocode first. Okay, so pseudocode is basically like our language. It means like do this, after that do that, and then after this do that. Okay, so it's like a basic instruction of what you want to do and the program want to do. So from the pseudocode later on, okay, we will create the algorithm, and from the algorithm we will go towards the coding. So right now we are in the left area, problem solving phase. So when you want to do like for example, you are from biology, or you are from chemistry, or you're from physics. I think there are any students from physics here? I don't think there are any. I think biology or chemistry, right? Okay, for example, you want to do analysis on certain chemical or analysis on certain substrate or something like that. Okay, what do you want to know first? What parameter you want to know? Is it the weight or is it the viscosity or something like that? Okay, you need to draft the the problem first. Okay, what you need to know, and from that you create a possible solution. Like for example, I'm not particularly knowledgeable in chemistry or biology, but in case of physics, okay, when you want to measure force, you need mass and acceleration, right? So when you do coding, okay, how much force does it produce? You calculate the mass and the acceleration. Where the mass come from? The mass might be entered by the programmer or the user of the program, and the acceleration also entered by the user of the program. No, no. Force is acceleration, not velocity. F equal ma. Am I right or am I wrong? I think I'm right. Yes, right. So check again your physics, your science. Okay. So when you conduct such analysis, okay, where you have chemical, right? So you have certain chemical. This is based on my experience with dealing with chemistry, right? You have a certain compound, a certain what you call it, a liquid, not a liquid, something like a chemical A, easier said. Chemical A, and you want to add with chemical B to produce chemical C. Okay, so where does chemical A come from? And then what is the weight of chemical A? What is the weight of chemical B? Or what is the final weight? And then to produce the what kind of final weight that you will generate of chemical C when you combine A and B. So this kind of problem solving is very important. It's like mathematical equation, something like that. Okay, after you have all those specification, okay, you will create an algorithm. Algorithm is simple. It's like a flow chart that you do in PowerPoint. Easy said. And then from the flow chart, okay, you verify it by creating a program according to that flow chart. Yes, you create a program by a flow chart. Okay, there are mind map. Okay, flow chart is kind of like a mind map, and from that mind map, you can create program. So you might think like, why do you need the flow chart? This programming is simple, right? So usually, okay, a top programmer, they will not only write a simple program, they will write a very, very big program. And for one large program, they will be separated into teams, okay? And there are a higher tier developer, means top tier developer, who create the general program, and the bottom one who create a smaller program. And when they want to troubleshoot, they create this mind map together. Okay, it's easy to troubleshoot using mind map first rather than looking at codes. Okay, so when you want to do, okay, that's what happened when you have a problem and you want to go to code. Okay, the problem is where you want to troubleshoot it, you have to look at code. Sometimes the problem is not only at code, the problem is at the algorithm as well. Means that you create the mind map wrong. So that's why your code works wrong. Sometimes it can, okay, like for example, last week you run your code, you build your code, you run your code. The build is successful, no errors, no warning. However, the result came out wrong. Where do you think the problem is? It's not on the code. The problem is in the algorithm, where you design the algorithm wrong. Okay, so usually we need to troubleshoot the algorithm first, and then we look at the code. The code is easy because your when you write your code blocks usually give you out errors. Where is the errors where you can check and fix? But when it comes to algorithm, okay, where you have you don't have errors in your code, but you have, like for example, when you do mathematics, right? You mistakenly write negative as positive. The end result will be different. Okay, the same thing. So where the problem is caused by the problem solving phase, which is under the algorithm. Okay, so like I said before, okay, remember the JK Rowling there. Okay, you have a source code, which is the script, and then you have the producer, which is the computer compiler. Okay, and then you have object code, okay, which is created for execution. Okay, this is where you have the movie there, and also you have a list of possibly errors. This is where you have the error that came out when you do the coding with code blocks. Okay, so when you execute, you will no longer execute the source code. You will execute the binary file, the executable file, the movie only. So your client will look at this area only. They will not look at your code. When they use your program, for example, for calculating something, and the result is wrong, okay, they will blame that your program is full of error. Even though your code blocks didn't mention any error, your program will be full of error. So what happened? Where is the error? The error usually in the source code where you have created the algorithm. Okay, so your algorithm might be the culprit there. Okay, so let's take a look at an example here. Okay, this is a sample problem. Write an algorithm to determine a student's final grade and indicate whether it is passing or failing. Now, this is simple command, simple software. The final grade is calculated based on the average of 4 marks. Okay, if the average mark is below than 50, the grade is fail, and if it's more, it's pass. So it's a simple code. Okay, now we do the pseudocode first. Okay, when I tell you the problem, what should you do first? Okay, first thing we need to figure out what is the mark. Okay, where we can get the marks. Okay, usually when we can get the marks is based on typing the marks in lah. Okay, so here we have input a set of marks. Okay, when the computer know what the marks is, what should he do? Okay, so here it's calculate their average. Okay, in this case you input a set of 4 marks, 4 students marks. Okay, and then you calculate the average by summing and dividing by 4. Means you add all those marks and divide by 4, you will get a result of the average. And take a look, if the result is below 50, print fail. Print here means that display in the screen. Okay, display in the screen. Like last week we have produced hello world there, right? So here we can that one I use print hello world. So in this case I use print fail. So they will appear in your screen fail, or else if it's more than 50, okay, in this case, okay, other than below 50 means that more than 50, okay, they will appear as pass. So a simple pseudocode here. So when we want to create a detailed algorithm, we divide them according to steps. Okay, according to steps. So the first one, we have step 1, input variables of m. M is mark. Okay, mark 1, mark 2, mark 3, mark 4. Okay, m1, m2, m3, m4. Okay, we have 4 marks. Okay, and then step 2, we take the average where we sum out all those marks and we divide by 4. Okay, and later on in step 3, we take a look at the variable grade here. Okay, and grade is less than 50, the result is fail. Okay, and if it's more than 50, the result is pass. Okay, so M1, M2 grade is similar like algebra here. Okay, in algebra you have X, Y, Z. Okay, so here is similar X, Y, Z, but in computing you will use more. So sometimes the combination of words, like for example grade, okay, grade is count as one variable. Okay, because it is connected all together, it count as one variable. This is one variable, one variable, one variable, one variable. So you have 4 variables add with each other divided by 4, you get the result for variable grade. Okay, so you guys got it so far? So far, okay?
Okay, Doctor.
Okay, okay, good. Okay, so next we will create the flowchart. So I don't need to explain to you what is a flowchart. Okay, I think most of you, basically when I mention to you flowchart, you might know, oh, I think I know what flowchart means, something like in PowerPoint or something like. So basically in dictionary, they mention a schematic representation of a sequence of operation, as in a manufacturing process or computer program. Okay, and technically is a graphical representation of those things lah. Okay, so when we use flowchart, okay, why we use flowchart is easier for us to show the logic of the algorithm. Okay, I know some of you like to read a lot of words, right? But myself, I hate looking at a lot of words that I have to read. I like it more visual, like their shapes, okay, colors, something like that. So I prefer to do flowchart more often. Okay, so we have a flowchart that is used to show the logic of an algorithm, okay, where they emphasizes individual steps and their interconnection. So you have steps and you connect those steps with each other using the flowchart. And you can control the flow of the flowchart from one step to the other, the next step. Okay, so basically in algorithm, if you look at algorithm, we have this kind of figures. Okay, this kind of what can I say is symbols. Okay, you can usually we use the oval, parallelogram, rectangle, diamond, and also the flow line. The hybrid one we rarely use it. Okay, I prefer to use the original formation with the lines. Okay, so each of them represent a function. Okay, where you have the oval, this represent the beginning or the end. Okay, And then you have the parallelogram here. Okay, here we have the parallelogram that denotes input operation, mean you get information from keyboard or you get information from a file. Okay, or you get information, if you are a very, very good programmer, you get information from camera or you get information from sound. Okay, so this is where your input is. And then you have a rectangle. So rectangle is where the mathematical operation is conducted. Okay, divide, plus, addition, everything. Okay, so this is where the mathematical operation is conducted. And then you have diamond. Diamond is for conditions. So condition, what do you mean condition? If okay, go left. If not okay, go right. Okay, that's why we have diamond. So you can go from top, you can go left, right, and down. Something like that. Okay, if this go left, if that go right, or if this print fail, if this print pass. Okay, we have diamond to do that. So let's take a look at the step example of the codes that we discussed before. You have 3 steps. So step one is input M1, M2, M3, and 4. So when you have M1, M2, M3, and 4 here, input, so means that we will use parallelogram here. Okay, so at the start, we have the oval here, and then next continue with parallelogram. And from there, you do the mathematical operation, which is the average, taking the average and put it into variable grade. So grade here, okay, is a result of mathematical operation, which is conducted in a square box. And after that, we have a condition where you want to look at whether if it's fall under 50, you want to press, if the grade fall under 50, you want it to produce fail. If it's more than 50, you want it to produce pass. Okay, here you have grade under 50. Yes or no? So if it's yes, print fail and then stop. If it's no, print pass and then stop. Okay, so it's a simple pseudocode here that you can create later on. Okay, next. Okay, next, let's take a look a little bit deeper in the flowchart. Okay, so basically a flowchart is a diagram, okay, that depicts the flow of a program. Okay, you have a figure here. Okay, so you want to calculate pay. Okay, so how many work hours, how many hours do you work? And then you take the result from the keyboard. Okay, this one, why is it parallelogram? Because it's an output. Okay, it's not only on input, it's in an output. So the program will display in the monitor how many hours do you work first. And then you read the hours, how many do you get paid per hour. Okay, and then you read pay rate, and then you have gross pay is equal hours time pay rate. Okay, and then display gross pay. Okay, so N. So basically, the flow chart, you see that this one is parallelogram. Okay, you have 5 parallelogram here, and then you have 2 rounded rectangle, and then you have 1 rectangle. So means that in your in your program here, you have 5 input-output process, 1 operational process, and that's all. Okay, you have start and end. Okay. Okay, so you have the terminal where you have the start and end, and then you have the parallelogram that represent input and output. Okay, and then you have a process box here that display the calculation that is operated in this program. Okay, so do you have any questions so far? Do you have any questions so far?
No, Doctor.
No, no. Okay, so like for example, in this case, you have see here, the codes here. How many hours do you work? Okay, so here it will replace how many hours did you work? Okay, means here you have a variable content, hours, what is the pay rate, what is the gross pay. Okay, and then, okay, you insert in the command prompt. Okay, I work 40 hours. You put 40, you type 40. And then in the computer, it record the variable for hours as 40. And then you go towards how much do you get paid per hour. And from here, you are filling in the pay rate. Okay, you paid per hour 20 ringgit per hour, for example, quite high. Okay, 20 ringgit per hour. So at here you have a variable content for pay rate is equal 20. Now to do the operation, the variable that is used inside the operation need to be available first. Okay, means that you have hours, you have the content here, period, you have the content here. If you do not have the content, the operation will not operate. So in this case, you have hours and period content, and finally they will calculate and insert that. At the end, your gross pay is equal 800. Okay, so this one is a simple mathematical process here. So basically, an algorithm is based on three main modules. You have input, you have process, you have output. Okay, so right now, let's take a look. Okay, I want you guys to share your screen for this problem. Okay, write an algorithm and draw a flowchart to convert the length in feet to centimeter. How is feet convert to centimeter? So this one I need you to Google. So that's why I ask you to have your PC here. And please use, in case of here, okay. Okay, please open a PowerPoint. Okay, I'm opening a PowerPoint here. Okay, open blank presentation, change the layout, blank. You have PowerPoint with you or not? Do you have a PowerPoint?
Yes.
Yes, we have.
Okay,
Yes, sir.
so please write an algorithm for how to convert the flowchart from length in feet to centimeter. So here, I show you. In PowerPoint, it's easy. I like PowerPoint. Okay, usually it's make things easier for doing flowchart. You have rectangle here, and then you have make it black and white. It's easier for me to see. And then you have shapes. So usually I will not use this oval. I will use something that looks like this. Okay, this. Okay. This one is the oval that I commonly use. And then for parallelogram, I will use this one. Okay. Okay, please take 5 minutes for you to construct this one. And I will ask randomly those in the list to show me your screen of what you are doing now. Okay. Okay, how are you progressing? Okay now?
Okay, Doctor.
Easy, right? So let me just demonstrate to you how I do it. Okay, can you see my screen, the one that I shared?
Yes, Doctor.
Okay. Okay, so here you have input, process, output, and terminal. Terminate. Okay, so you have this one, start. Okay, end. Okay, input, hit value. Okay. Okay, as usually display enter value in feet. Then we have another one here. Read. Okay, so just not make you confused. Value in feet. Okay. Okay. With value in feet. And then value in.
Doktor, kita memang kena letak underscore ke dekat situ?
Okay, why I put the underscore? Okay, basically in computer, okay, value in cm, I see what you do. Value in cm is equal to how? What is the operator? What should you times? Divide or something like that. Can anybody tell me what is the operation to convert value in feet to centimeter?
Value multiplied by 30.48.
30.48.
30.48.
Like this, huh?
Yes.
Okay. Okay, so okay, now I explain back why I do it like this. Okay, this one. Okay. Okay, why I do it like this? Okay, why do I do it like this? Okay, this one, I want it to be as one variable. Like, for example, we have, okay, variable x, okay, or y, right? So in programming, okay, if it's a continuous words, is it a continuous if it's a continuous alphabet, okay, alphabet symbols, something like that, this one counts as one variable. This one is counted as x, okay. So value infinite, this one also count as, for example, y. So when you put underscore, it count as one variable, either x or y. But if you put space, in this case, okay, it doesn't count as one, it counts as 3.
Invalid.
Invalid. Okay, so that's why I put underscore. So it counts as 1. Okay, sometimes people, they don't like to use this kind of underscore. They just make it close with each other. Okay, this one also count as one variable. Okay, value infinite. This one count as one variable. You can do either way, but you cannot use operational symbol. Like for example, what kind of operational symbol that you have? You have divide, or you have multiply, or you have equal, okay? Or you have this one, okay? This one you cannot use because it is used by the compiler as an operational symbol. So that's one, okay, if you put it, there will be error because it doesn't count as a normal algorithm symbol, like normal variable symbol. Okay, so they will count as operational symbol. So you need to be careful with it. Even some programming language, okay, like this, okay, first this one, what you call it? What you call it in English? Whatever, this kind of symbol. Okay, this symbol is also sometimes being used by certain library, okay, to represent something. So you cannot use it. You cannot use it commonly. And sometimes this one, okay, is used to terminate a line. Okay, this one is usually in C++, so you cannot use it in C++. So for variable, please try to refrain use a lot of symbol other than underscore. Okay, underscore. Okay, you cannot use minus as well because minus is an operator. So you need to be careful with that. And even percent is also as operator. You cannot use them. So okay, let's continue here. So once you finish, you get, okay, like for example, display value in CM. So what happened here when you do this? Okay, you need to create the arrow. Don't forget the arrow. Okay, arrow need to be black in color. Okay, you put arrow to represent the relationship between all these box. Okay. Okay. So later, why the arrow is important? Because the arrow might go back to the previous process. Like for example, from here, okay, later on in the future, you will learn some other operators that do something like this. So means that after here, you go back to here. Okay, so that's why the arrow operation is important. So don't play with it. Don't take lightly of it. Okay, here we have input the length in feet. Okay, calculate by multiplying length in feet. LFT here, the variable that is used in the slide is LFT. Okay, length in feet, and then for variable for cm is length in cm. Okay, so at the end they print the length in cm here. Okay, so when you create your flow chart, it will be like this: input. Okay, step 2, get length in cm, and then print length in cm. This one more simple lah. Okay, so try to make it as detailed as possible because detailed algorithm and flow chart make troubleshooting easier when you do coding later on, especially in your calculation lah. Okay, for example 3, okay, this one let's just go towards the result. Write an algorithm and draw a flowchart that will read the two sides of a rectangle and calculate this area, its area. Okay, so means that this algorithm, okay, this algorithm is for program to calculate the area of a rectangle. Means you have two areas here. Okay, you have like for example, in case here, input the width of the rectangle, and then you have the length of the rectangle, and you will calculate the area by multiplying L with W, and then you print out A. Okay, so example here you have input width and length. Okay, and then you calculate the area equal length times width, and then you print out the area A. Okay. And then next is for a little bit more difficult. Okay, write an algorithm and draw a flowchart that will calculate the roots of a quadratic equation. This is much more likely more related to you guys. Okay, pure science. You might like math so much. Okay, Okay, for quadratic equation, how do you get the root of quadratic equation? So you need to find out the formula, and formula of the quadratic equation is minus b plus d divided by 2a, and minus b minus d divided by 2a. Okay, you guys still remember quadratic equation? Forgot already. Okay, so d here is square root of b power of 2 divided by 4ac. Okay, so when we calculate the codes, we want to create the algorithm. Okay, you put the coefficient a, b, c of the quadratic equation. Okay, this coefficient a x power of 2 plus bx plus c. Here you have this coefficient of a, b, c, and then you calculate d. So d is equal square root of b power of 2 divided 4ac. Okay, SQRT is not a variable here. This one is a function. Function to calculate square root of the content of this bracket. Okay, so this one later on you will notice that we will use certain functions to do certain operations. Okay, so square root divide means that b power of 2 minus 4ac is divided by b power of 2 minus 4ac 2 times. Okay, and then when you calculate x1 and then calculate x2, you print x1 and x2. So how do you do it? Okay, the algorithm is input A, B, C, D equals square root of this. Okay, you see that it's just not simply put B power of 2, you put B times B, okay, minus 4 AC, okay. So for C languages, okay, power of 2, basically it doesn't exist. So for power of 2, you have to do B times B. But there are some libraries, okay, available online that you can utilize to make power of 2, power of 3, power of 4, or what, and easier. So usually we use those libraries to make our coding easier. So what are libraries exactly? Libraries are a generic codes, okay, that has been created to support the programmer. Okay, so people sometimes make money out of libraries. Okay, they create libraries. Okay, this library can help you simplify your code for doing this kind of calculation. So please buy my library. Okay, so they can use those libraries, okay, to make sure that they can put the shorter code. Okay, like for example, square root here is a part of a library. Okay, if not, you have to divide 2 times. Okay, divide divide b times b minus 4ac. Here you have to divide it with itself to get square root. Okay, is it correct? Divided square root. No, it's not correct. Okay, you have to do certain calculation to get the square root here. Okay, so that's all for today. Okay, do you have any question? Do you have any question? Do you have any question?
No, doctor.
No.
No, doctor.
Okay, now let's open your code blocks. Okay, let's open your code blocks. Okay, next let's have fun with your code blocks. Let's just do some simple code here. Okay, open file, new, empty file. And from here, save as first. Save file as, okay, I put chapter 1, exercise 1. Okay, so here how do you start a coding? Okay, usually you start it with void main double bracket and two bracket with I don't know what is name. This one is a normal bracket. This one is a curvy bracket. I usually call it curvy bracket. Okay, so once you do it for the curvy bracket, just put in space. So you have a space to write your codes here. Okay, so in case that you want to do a calculation, simple display, like for example print hello world. Okay, so this one, print is a function that can only be provided by a library called stdio.h. Okay. So stdio.h is a library. We call it a header file. .h is header. So you see the codes here is .c. .c is where you write your code. C. .h is a header file for a library. So this library, okay, this is also count as standard input-output library. Okay, they operate a function of print here. So when you type in print hello world, the hello world will appear in your terminal. Okay. Oops. So when you have this library, you want to include in your code, you add, okay, hashtag. Usually hashtag. I didn't call it hashtag during my time, but right now people people more familiar with hashtag. Okay. Include stdio.h. Is it correct? Incorrect. Sometimes I forgot about the syntax or something like that. Okay, yes, that's supposed to be correct. Include stdio.h. Why the green? Okay, now when you want to produce your result here, okay, let's build it first. Build. Oh, you have error. This one is common problem where you use to another programming language. In C++, for every line of codes that you have within the function of main, okay, you need to put in this one, semicolon. Okay. So when you build, two error, unknown. Print hello. Oh, sorry, not print. Print F. Okay, sorry. Print F. Okay, I'm too used to. I just finished coding in another language. So okay. So print F, hello world. Okay. So print F means that it will print out the hello world in your display. Okay. So why do you use this bracket? Okay, because you can shorten your codes like this. Okay. So that's why we use this one. Okay, the main function here, this is what we call function. Main function has the operation of printf hello world. So print here is referred to the library stdio.h. So when you build, no errors, and when you run it, this will appear where you have hello world. Okay, so this one will appear in your terminal. Okay, so right now I want you to open your code blocks and try to edit the hello world here into other things. Selamat tengah hari cikgu, like for example. Okay, so when you build, what happened? No errors, and you got this result. Selamat tengah hari cikgu. Okay, so please try and do this first. Okay, if you have a problem, okay, you can raise your hand or talk to me, or just open your mic and talk. Talk. I am available here. Okay, please try and do this first. Okay, everybody got your code blocks already?
Yes, doctor.
Okay, so when you want to display, okay, in case you are creating algorithm here, okay, when you create algorithm here, the algorithm here only behave like this. Okay, look at, you can just create start. Okay, this one is, okay, you have an output process. Okay, and you have an end. So here you have start, and print, F. Okay, then you insert your arrows. Okay. Do you understand? Do you understand?
Yes,
Okay.
Doctor.
Okay, refer back to this one. Okay, if you cannot see more clear, I'll focus a little bit further. Bigger. Okay, big enough? Big enough? Okay. Okay, I will upload a lab session down here. Okay, starting this week. So the lab session will be a problem that you need to solve, create the codes, okay, and then you will upload your codes inside. For this week, I think not code yet. For this week will be flowchart. Then I will need you to upload your answer into the Google form and submit it online. Okay, so there will be a session, and then I will give you an answer during the period as well. At the end of the class, I will provide answer. You can look back on what you did. Okay, so please make sure at the lab time you look at the question and the answer properly so that you can understand what you should understand. Okay, so I guess that's all for today. Do you have any questions so far?
Doctor, will you upload the lecture notes inside the Kalam also?
Okay, I will upload the lecture note inside the Kalam as well for this week, and also the video. Okay, so reason I'm using this kind of method is that so that somebody who has disconnected from the class can still keep track of what they lost later on. Okay.
Okay, Doctor, thank you.
Okay. Anything else?
Doktor,
Yeah.
yang GC tu apa dia, Doktor? Doktor
Huh?
kata Google Classroom tu.
No, kita tak pakai Google Classroom, kita akan pakai Kalam je.
Alright.
Okay.
Noted.
Okay, anything?
Doktor,
Yeah.
lepas ni untuk lab memang tak ada kelas dah ke?
Saya rasa saya tak perlu buat untuk kelas lah. Kita buat like exercise, you submit. Macam tu saja. Okay.
Okay.
So,
Doktor,
yeah.
jadi submit terus dekat pukul 8 lah masa tu.
Saya
Pukul
akan
8 masa kelas.
masa kelas. Saya akan buka masa kelas dan you akan submit masa kelas. So, I akan buka 2 session. Session pagi dengan session petang. Soalan lain-lain, you have to submit according to that lah. Okay?
Okay, Doktor.
Okay. Any other question?
No, Doctor.
No? Okay. Okay, I think that's all for today. Okay, we continue our class next week. Okay, so I see you guys later on. Assalamualaikum.
Thank you, Doctor.
Thank you, Doktor.
Thank you, Doctor. Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.